Hello, how do we use inverse properties of logs in the inverse functions of logs? Well, first let's figure out these inverse properties. And to do that, you can see it if you just rewrite exponentials as a log and rewrite this log as an exponential. Think about rewriting this one as a log. You'd have log base b of b to the x equals x. Log base b of b to the x equals x. So here we see that if we have log base b of b, right, to the x, it's all equal to just this x. So if this base is the same as this base, you just get x. Or rewrite this as an exponential. This would be b to the log base b of x equals x. B to the log base b of x equals x. So again, if these bases are the same, it's just this x. So another way of looking at it is sometimes we just want to make them the same base. Here we have log base 2 of 8. Well, we know that this is equal to 3 because, 2 to the third power equals 8. Well, check this out. I could write this as log base 2, and now I could change the way I write 8 as 2 cubed. All right? That's the same thing as 8. And now we see by our log properties, if these bases are the same, it's just equal to this exponent. A second ago we saw that that was equal to 3 as well. All right, so let's try to use some of these properties. In the first example, log base 3 of 3 to the x, because these bases are the same, our answer is just x. Here we have log of 10 to the 2x. Remember that if we have a log, this is a common log, which is a base 10. So these bases are the same, so the answer is just the exponent of 2x. Here we have log base 2 of 16 to the x. Well, I'm going to have to rewrite 16 as a 2, as a power of 2. So it'd be log base 2 of 2 to the 4th power to the x. So I just rewrote 16 as 2 to the 4th. Now, I can rewrite this again as log base 2 of 2 to the 4x, because of power to a power, you multiply them. Now that these bases are the same, the answer is 4x. All right, you try the next three using the other property. All right, hopefully you got 3x here because 5 to the log base 5, these bases are the same, so it's just this 3x. Here the bases are the same, again, because this is a log base 10. And, of course, e to the natural log of 7x, that's a log base e. All right. All right, now we're going to find the inverse algebraically, and this is one of the most important pieces here of why we need logs. Just like any inverse, the very first thing that we do is swap x and y. And then we're going to change from a log to an exponential, or vice versa. And that's because the inverse of a log is an exponential. Okay, and then we'll just solve for y. So let's do this. We'll swap x and y. Log base 7 of y equals x. Now change from a log to an exponential. Well, this would be 7 to the x equals y. Solve for y. Well, this is already solved for y. All right, we could do it the other way. We swap x and y. X equals 7 to the y. Rewrite as a log. So this would be log base of the exponent, so base 7 of x equals y. And we see that these two things were just inverses of each other. All right, so let's try to do that again. Here, we'll swap x and y. X equals the natural log of y minus 4. Notice that the y minus 4 is in parentheses. Rewrite as an exponential. So what's the base here? Well, the base would be e. So whenever I rewrite this as an exponential, this would be e to the x equals y minus 4. You can get y by itself. E to the x plus 4 equals y. This is the inverse. Let's do it again. X equals 3 to the y minus 4. I need to get the exponent by itself, or this 3 to the y by itself. So I'm going to start by adding 4. So x plus 4 equals 3 to the y. Now that I have the exponent by itself, just like here I had the log by itself, I'm ready to rewrite it as a log. So this would be log base 3 of x plus 4 equals y. And that's solved for y. Here, you try the last one. All right, so hopefully we got 10 to the x minus 4 equals y. We subtracted 4 first. This is a base 10, so we rewrote it as an exponential, and then it's solved for y. All right, and that's all for today. Goodbye.